Okay, so the next thing we have to look at is something we did in year 12 and year 13, where we would have added together resistors. We want to see how we add together capacitors, because this can make it easier to identify what's going on in circuits. So really what we're looking at here is we have three capacitors. First thing case we're going to look at is when they're in parallel, and we want to see what is the equivalent single capacitor. We'll essentially do the same thing as those three capacitors in that circuit. Now, if we just look at the first capacitor C1 here, we have a rule which is that in any loop around the circuit, the voltage has to add up to the voltage of the supply, which means the voltage across this capacitor here must be the same as the supply. Likewise, C2 and likewise C3. Therefore, just looking at the first capacitor, the charge on the first capacitor would be Q equals CV, so C1 times Vs. The charge in Q2 or in the second capacitor would be C2 times Vs, and the charge in the third capacitor would be that. In this case, the charge on the total charge really would be equal to the supply voltage times CT, okay, the total capacitance of these three equivalent capacitors. So what I can work out is that QT is equal to Q1 plus Q2 plus Q3. Okay, the total charge stored in this system is going to be the addition of all the charges in all the three separate capacitors. Now, if I sub in this for this and each of these values into this equation, I get that Vs times CT is equal to C1 times Vs plus C2 times Vs plus C3 times Vs. We can divide each of those by Vs and we end up with the outcome here, which is really the important thing, is you will need to know how to use this. But in parallel, we add the capacitances of the separate capacitors. So if you notice, we do the opposite thing that we would do with resistors. So for instance, if I had this circuit and this first capacitor was, say, 2 microfarads, and this is 1 microfarad, and this was 3 microfarads, well, my total capacitance of that system would be C1 plus C2 plus C3, which would just give me 6 microfarads. Okay, so in parallel, we add the separate capacitances to find the total capacitance.